Hello everyone. So good evening and good morning to all of you. And today here I am going to walk you through the complete mini project or kind of assignment that I was working on for a couple of days. And the project is about fast API repository chat agent where we are targeting to build a production ready multi-agent system that can answer questions about the fast API code base. So right now we have built it for fast API, but in future there's a scope that we can integrate any kind of repository and we can ask queries related to that. So the system is architected using MCP, which is like Model Context Protocol, and each of the agents talk over this MCP tool only, and they try to address the user query, and then finally they also try to synthesize the output and generate the final answer. So if you look at the objective, so here each agent is an independent MCP server. So here we are mainly having three agents. One is an indexer agent, then second is a graph query agent, and third is uh, the code analyst agent. So these three are the agents. Each of these are having their own tools which we'll go through, and then there is orchestrator which try to like check which agent to call and answer the user query using its like system prompt that we have written for the orchestrator. So this is the objective, and here you can see the system architecture wise. So overall we need one orchestrator agent, and this is the responsibility of that agent. Then we need these tools to have inside the orchestrator agent, and all these tools are MCP tools. Similarly, we have indexer agents whose task is to parse the complete repository, fast API repository into graph DB. So there is a shared infrastructure for a graph database using Neo4j, and all these files that are there, we extract nodes and relationship, and we try to index them, and then basically store this information inside the graph database so that we can retrieve the information as and when needed based on the entities or relationship that we already defined. And then we have this graph query agent which helps us in querying the graph database that is there based on the orchestrator demand. And these are the MCP tools that it is having. And then the code analyst agent which go through the code line by line or at a high level or a function level, class level, so like those kind of things. So it's a detailed responsibility here, and it is also having couple of MCP tools. Now there is a shared infrastructure as I told for Neo4j, and then we also have like manage memory over the conversation if we are going for. So this is the overall communication flow that we are targeting to build, where like user will ask the query, and then if you look, the fast API will be the gateway through which all of these will be connected, and then the orchestrator will come in picture. It will take the user query, and then it will check all the agents that it is having, and based on the tools it will try to call the particular agent in a React format, and then the agent will run its own tools and try to brainstorm and think what answer it can return back to the orchestrator. And then similarly it will go through all the three agents, and finally the response it will try to synthesize the orchestrator, and then so whatever is coming here, and then finally it will generate the response. So we will also review like some of the uh, queries and how it's performing on that. So with that, let's go and dive into the architecture of this complete repository. So far I think it's clear, right? So if you look at the architecture here, so this is how it is. Let me just zoom in a bit. Yeah. So here if we look, first the user will pass the query, and then it will try to go through the fast API gateway, which will be kind of UI that is hosted at port 8000, and then based on the method REST SSE or WebSocket, it will trigger the orchestrator. So orchestrator MCP call will be played. So here is the MCP, and it will be based on the session ID and the query that the user is giving. Now orchestrator is having its own brain and also some conversation memory that from its previous conversations, and then it will plan, delegate, ask again, and synthesize. So basically it will run in a loop, and unless and until the query is answered, it will keep on delegating the task to a certain agent that we have, and then again check if the answer query is answered or not, and if it's answered, then it will try to synthesize it and then generate the response. So these are the four tools that our orchestrator is having: analyze query, then route to agent, then get conversation context, and then synthesize response. So all these query we can see here in this folder. So this is my app folder, and inside this we have agent, and here we have the orchestrator. So in the orchestrator we have this agent clearly shown here. So we can see the different agents that are there, like this agent or this agent, get conversation context, or to agent, agent, and then synthesize response. And then there is a server which hosts all of these as an MCP server. And in the end, we also try to Dockerize everything. That's why we have this Docker file. And we follow a similar structure for indexer, graph query, and the code analyst agent as well. Now, as it comes down, so the orchestrator decides, let's say, that it has to assign a task to the graph query and fetch some entities details based on the user query. So let's say if user is asking about depend class, so it will figure out that this is a entity, and based on that it will try to fetch the information from this graph database. So for that it will again pass that to graph query, and then graph query will have its own system prompt, and it will try to again run its own react loop and try to call the relevant MCP tools, again using HTTP or fast API call, and then fetch the correct information, and then it will try to send it back to this orchestrator. Similarly, based on whatever information it receives, and then it will again pass it to code analyst, and then code analyst will try to summarize that information or fetch the relevant information, or if it is asking to get some code around that. So all those things will be happening. Now once all these things are done, so the user will get the query. But you may have this doubt that how the graph query is created. So graph database is created basically. So that's why we have this indexer. So this indexer will be run initially before we ask any query, so that the graph database is available to answer the query, right? So that's where this indexer will have its own brain. It will try to go through each of the folders and files that are there inside the fast API repository, and then it will try to pass each of these Python files, extract the different entities that we have defined, like classes, functions, and modules, and based on that it will try to also extract the relationship, how it's related to one another, and then finally it will try to generate the index, or basically generate the graph, right? So this is the overall flow, and that's where these two are sharing the same like infrastructure. Now if we come to fine, let's go and try to understand the folder structure in detail. So here is my code analyst agent. You can see inside agent, and then again we have this Docker file. If you look at the Docker file, it is like this. So we can go in detail in each one of them, but overall the folder structure looks similar. So this is the different MCP tools that we have written, and then in the server you can see we are calling all these MCP functions and creating the MCP tools. So here you can see, and which can we can utilize once we are hosting this on the Docker or on local server. So similarly we have it for all the agents, and then we have some configurations and database related information, and then some gateway to make the communication happen, and some models around like entities and graph relationship that we are going to have. So yeah, this is on high level. And now if we go back to the architecture, so we have also written the stepwise process, like what all things we need to do to run this in local or in the in Docker container. So at first, if we are going to run it in Docker container, we need to start our Docker container. Now you can see in the container there is no jobs running as of now. So first of all, we need to check the environment files if they are available or not. So you can see we have .env examples where we can see the all the different configurations that are required. Like we should have a LLM access. So here we have selected three, but either one of it should be accessible. That's why uh, it can select from these three LLMs and try to work on that. And similarly for Neo4j also, we need to define a username and password. And so once you go through this env example, you can see this details are there. Again, it's not necessary to give all the information of all the LLMs, but just one is fine. So here you can define that, and here is the Neo4j related information. Now, in order to start the Docker container, so you have to run this command docker compose build d in the terminal. So I have already cloned this repository in my let's say this one VS Code. Now I am running this. Once I run this, it will initialize all the first it will try to create all the images based on the docker compose file that we have here. So this is the docker compose file. So if you go to the docker compose YAML, we have configured all the different servers. So since it's the requirement that all these agents and orchestrator and this Neo4j should be hosted on their own separate server, so that's why we have these services running as separate server. Now if you go to the containers here in the Docker, we can see all the servers are here, all the containers are built. Now it is going to start all of them in some time. So let's wait for a couple of seconds. Now as you can see, all the containers are up. You can see the buttons. Now we can try to go and take a look into each of these containers as well, but for now we'll just focus on the UI and the Swagger and the Neo4j. So first of all, you need to go to the UI. So for that we have this gateway thing. So if you click on this link, it will take me to the UI screen. So here you can see this screen, and if I want to go to the Swagger, which is kind of understand what all different APIs that are working here, so I will just open that. So these are the different APIs that are working. Now we can check the health of all the LLMs, and if we have at least one LLM which is active. So let's try to check it out. So here you can see OpenAI LLM is configured true, and then credits are available. So we are good with the LLM, at least with one. Now once this is done, then the second thing is we can check the health of all the agents that are there. So let's try to execute and see the agent's health. So you can see the indexer agent, then the graph query, graph code analyst, orchestrator, all agents are working good. Even the database is connected. So the Neo4j is also configured properly. So far we are good on this. Now to start the indexing, we have this API index. So once we try it out, and we have to paste the URL. So the URL again will come from the repo. I have already mentioned it there. So here we have the fast API URL. I think this one. So if we try running it, we will be able to once I execute it, so I will be able to start generating the graph one by one. But if you check the statistics now, so this is telling me what is the current graph, is there any nodes or not. So that detail is trying to generate. So if I execute this, it will show that this particular repository is already indexed, and there are total 1136 files which are indexed here, and total entities around 16,000 extracted out of this. Out of these, these are the different entities types that it extracted. So a kind of a high level detail it tries to provide here. So since it's already indexed, I am not going to rerun it, but in case if you are running it, so once you trigger this it will try to give you a job ID, and then using that job ID you can track the status from here, this status job ID. So you just need to enter the job ID, and I think you will be able to understand whether it's running or not. uh, let's try to go through some of the queries and also Neo4j graph. In the end, if there is some time, I will try to run this indexing once again. So before jumping to the query, let's also try to visualize the new graph, Neo4j data graph that we have created. So let's try to open the graph here. So we have this local URL set up here, and then the password also written. So let's try to connect it. Yeah, so this is the graph database that got created, and total nodes, you can see the matching is there, and then total relationships is around 6 lakh relationships. So these are the high level relationship kind that is shown here, and then these are the different entities or classes nodes type that are extracted. So now let's try to run some of the cipher queries to understand how it works. So let's try to check the count of all the nodes that are there using cipher query. So here you can see total count coming as 16, which is correct, which we already saw there. And then similarly, we can also count the relationships. So you can see 6 lakh 40,000 around relationships are there, which is also matching. And then we can also try to check the node type count, so category wise. So you can see import is having 4,600, and if we try to check it from the Swagger, so 4,600, yeah, import 4,612, so it's matching exactly. And similarly we have it for other node types as well. And in a similar way, we can also try to visualize the relation type categories wise count. So if we run it here, so you can see contents is around this many relationship, hash parameter around this many relationship. Now if we want to just visualize some of the nodes which belongs to class, so just top 5 nodes, so we can run this, and you can see the nodes are here. So these are the nodes, and if we click on it, we can see the details on that, like from which file it is coming, and what is the line number, and what is the module that it belongs to. So this, and if you double click on this, it will expand all the related nodes around it, and then you can keep on seeing that kind of relation again, what all things it is related to. So yeah. Now similarly we can do for edges as well. So here if we try to execute this, we will get uh, the 4 or 5 edges that we can see all belongs to contents. So if we change it from contents to some other, maybe depends on, and try to run this, we'll see the depends on relations. You'll see. Now let's try to run this one last piece where we have explicitly mentioned the name of the node, which is fast API routing, and this is a module name. And let's try to see like something related to this node. So you can see this fast API routing node is there, and these are the relationship that is each having. So we can change the count as well, so that we can see more and more relationships around this, like this. So this is how the graph agent will also try to run and fetch the information from this graph database. Now let's try to jump into some of the queries. So maybe I can try to create the query video, a different video. So we'll try to show it there. Thank you everyone. Yeah. Hope you understood the project structure and architecture, and yeah, we will be going through how it is performing on real-time queries now. Thank you, bye.